Hi everyone, welcome back to Lulumath. This video is on equations with no solution and equations with infinite solutions. And we're not only going to take a look at equations with no solutions and infinite solutions, but we're also going to identify how do we know if an equation has no solution or has infinite solutions? And what does that mean? What does it mean to have an equation with no solutions or infinite solutions? So for starters, you're going to need to know how to solve multi-step equations, and you're also going to need to know how to do some checking of solutions in equations, because understanding these checks will help us to understand why we end up getting no solution or infinite solutions. If you need a refresher on either one of those topics, both of those videos are available at lulumath.com as well as the Lulumath YouTube channel. So let's take a look at our first question we have here. We want to solve the following equation, and I'm just going to go through and do a quick solve of the equation because I'm not as concerned about how to solve the equation as I am about what happens when we get to a point where we have infinite solutions or no solution. So the first thing I'm going to do is distribute. So I'm going to multiply the 2 through to the a as well as to the 1. So 2 times a is 2a, and 2 times 1 is 2. Then I'm going to distribute the 3 through, so I get 3a and negative 9. Equals, distribute the 5 through, and I end up getting 5a minus 20 plus 13. Now I'm going to combine my like terms or collect my like terms. So 2a and 3a go together, so I get 5a. 2 and negative 9 go together, so I get negative 7. And then on the other side, I have this 5a and nothing is like it, so I'm going to copy that down. And then I have negative 20 and 13, and when I put those two together, I get negative 7. Now I want to get my variables together on one side and my constants together on the other side. So I'm going to get rid of my variables first. So I'm going to get rid of this 5a that I see here. Well, to get rid of that positive 5a, I'm going to subtract 5a, and let's see if this really works. 5a minus 5a is 0, which is what I want. But whatever I do to one side, I do to the other side. And look what happens. I have no a's left over on either side. So I end up getting an answer that says negative 7 is equal to negative 7, which is a true statement. So since this is a true statement, what does that tell us? Let's take advantage of some technology that we can use to see what this really means. So if you see here, I'm using Desmos, and on the top line, I took the left side of the equation and I wrote it out. And on the second line, I took the right side of the equation and I wrote it out. And I'm going to add a slider for a. So when a equals 1, it tells us here that our result is negative 2. And on this side, our result is also negative 2. So does that mean that the answer is 1? Well, let's do a check and see what happens. So every time I see an a, I'm going to replace it with 1. And now I'm going to follow order of operations to evaluate each side of my equation. So on the left side, I've got parentheses or brackets. So 1 plus 1 is 2, and then 1 minus 3 is negative 2. And then I'm just going to copy the rest of this down. So this is 2 times 2 plus 3 times negative 2. Now on the right side of my equation, I have 1 minus 4, which is negative 3. Copy down the 5, and then we get plus 13 here. So now I'm going to do my multiplication. So 2 times 2 is 4, 3 times negative 2 is negative 6, 5 times negative 3 is negative 15, and then I'm going to just copy down the plus 13. And then 4 minus 6 is negative 2, and negative 15 plus 13 is negative 2. So it checks, it works. A equals 1 is a solution to my equation. So does that mean that Desmos just knows that a equals 1 is the answer? Well, let's see what happens if we change the value of a. So instead of a equals 1, I'm just going to randomly slide this over and see what we get. So now we've got 5.1. And on the left side of the equation, I get 18.5. On the right side of the equation, I get 18.5 again, which means my two sides are equal to each other when a is 5.1, which means that 5.1 is also a solution. Negative 7.4, I get negative 44 on both sides. 10, I get 43 on both sides. It does not matter what my a value is. I always end up getting the same answer on both sides, which means that any solution will work here. And like we said, a could be any random number. It doesn't even have to be a rational number. So I could even use pi. If I plug pi in, it doesn't matter. Both sides of my equation are still equal to each other. I could use the square root of 3, for example, and both sides of my equation are still equal to each other. I could have the most random number for a. So I could say a is equal to, I'll put in a fraction and I'll say 5 minus the square root of 7 all over 4 pi. I'm just making up a random expression, and still both sides of my equation are equal to each other. This equation that we're looking at up here has infinite solutions. And it all comes down to this point right here. We got to a point where we have 5a minus 7 equals 5a minus 7. When my equation is completely simplified on both sides, they are identical. Both sides are identical, which means a can be any value. Therefore, this equation has to have infinite solutions. So let's take a look at this next equation. 3b minus 3 equals negative 2b plus 7. So the first thing I'm going to do is I'm going to get my variables together on one side. So I'm going to get rid of this negative 2b by doing the opposite of it, which is adding 2b. And negative 2b plus 2b is 0, so that will cancel out. So I end up getting 5b minus 3 equals 7. I've gotten all the variables on the left side, which means I don't want constants left over on the left side. So I'm going to get rid of this minus 3. And to get rid of that, I'm going to add 3. Negative 3 plus 3 is 0. So that cancels out, which is what I'm looking for. So then I have a 5b left over on the left side, and 7 plus 3 is 10. Now I'm just going to divide everything by 5 to get 1b left over, and b will equal 2 because 10 divided by 5 is 2. Now, when I do a check here, and I replace the b value with this 2 every time I see a b, I will have 3 times 2 minus 3 equals negative 2 times 2 plus 7. So now when I evaluate this here, 3 times 2 is 6, and negative 2 plus 2 is negative 4. And 6 minus 3 is 3, and negative 4 plus 7 is 3. So it checks, it works. We know that when I take 2 and I plug it in, this solution will work. Well, in the last example, no matter what value I plugged in, my solution worked. But in this example, let's try a different number. Let's try b equals 1, for example. So every time I see a b, I'm going to replace it with 1. So now when I evaluate, 3 times 1 is 3, so I get 3 minus 3, and negative 2 times 1 is negative 2, and 3 minus 3 is 0, and negative 2 plus 7 is 5. So this is false. This does not work. 0 is not equal to 5. Therefore, b equals 1 is not a solution. But b equals 2 is a solution. And in fact, it's not a solution, it is the solution, the one and only answer that will satisfy this equation that we have here. So if you see here on this line right here, I wrote the left side of the equation. On this line, I wrote the right side of the equation. And I'm going to add a slider. And when b equals 1, we get 0 on one side, we get 5 on the other side, which is what we just showed right here. And no matter what b value I plug in or I change this b value to, it doesn't matter what it is. The answers are not the same unless b is equal to specifically the value of 2. That's the only time they're equal to each other. So I got rid of the slider and I added y equals in front instead. So if you look here, it shows us that our graph intersects at the point 2, 3. That's the only place that works on the two parts of my equation, the 3b minus 3 and the negative 2b plus 7. And we're only looking for the b value, and the b value is the first number that we have in our coordinate here because it's like the x here. This b is like an x. So this point right here is telling us that 2 is the solution, and that when I check my solution of 2, my result is 3. So just like we had right here, 2 was our solution, but when we do our check, we ended up getting 3 when we evaluate 2 on each side of my equation. So let's see what happens if we look at our original equation that we looked at and we graph out the left side with y equals and we graph out the right side with y equals. So I turned off the bottom two equations and I'm going to turn on the top two equations. And if you see, the left side of our equation that we were looking at is represented by this red graph, and the right side is represented by this blue graph. And when I switch back and forth, if you notice, they're the exact same graph, which means that these two graphs will intersect everywhere. So every single x value that I plug in will work on both sides of my equation. I'll get the same result regardless of what my x value is. All right, so now let's take a look at our last example that we have here. So again, I'm just going to solve this like a normal equation. So I'm going to start by distributing the 2 through. So 2 times c is 2c, 2 times 4 is 8, and then I'm going to copy down the minus 3. Then I'll distribute the 5 through, so I get 5c, and then 5 times negative 2 is negative 10. Now distribute the negative 3 through, so I end up getting negative 3c, and be careful, this becomes a positive 9. All right, beautiful. Now that I've done that, I'm going to just collect my like terms. So on the left side, I only have 2c. There's no other c, so I don't put anything else with it. I copy that down. And then I have 8 minus 3, which can go together, and I get 5. Now on the right side, I have 5c and negative 3c, and putting those together, I get 2c. And then here, I have negative 10 and positive 9, and putting those together, I get negative 1. Now I'm going to get my variables together on one side. So I'm going to get rid of this 2c. To get rid of it, I would subtract 2c, and whatever I do to one side, I would do to the other. 2c minus 2c is 0. That's nice. But on the left side, 2c minus 2c is also 0. Now be careful, because a common mistake that I'll see is people will say, oh, the 2's cancel out, but we still have a c left over. So I'm going to say c plus 5, which is not correct, because 2c minus 2c is 0c, and this c right here is saying that we have 1, which means that we're saying that 2 minus 2 is equal to 1, which is not true. And you also want to be careful of that mistake right here as well. 5a minus 5a is not a, because again, 5 minus 5 is not 1, it's 0. So 0a, we don't even write that down. So I end up getting to a point where I get 5 equals negative 1, which is not true. 5 will never equal negative 1. They're never going to be the same number. It's not possible. So what is this telling us? This is telling us that we don't have any solutions. It's impossible. I cannot find a value for c that will work in this equation. And it all comes down to this part right here. This part right here is saying 2c plus 5 is equal to 2c minus 1. So this is saying 2 multiplied by some number, and then you add 5 to it, is going to equal 2 multiplied by that same number minus 1. And if I add 5 to this number here, I'm subtracting 1 from the same number here, which is not possible. I will never get my two sides of my equation to be equal to each other. Let's take a look graphically why this doesn't work. So I'm going to type in the left side of my equation with y equals, and that's this green equation that we got here. Then I'm going to type in the right side of the equation, which is this purple equation that came up here. And if you see, we end up getting lines that are parallel to each other. And parallel lines by definition will never intersect on the Cartesian plane, on the coordinate system here. Therefore, there is no value of c that will give us the same answer on the left side of my equation as it will on the right side of my equation. And this is also known as the null set. So we can write our notation as follows, and this means the null set, which means there is no solution. So let's summarize what happens. Whenever we solve an equation, we have one of three options or one of three scenarios. The first scenario is we get one solution. And that happens when we end up getting our variable is equal to some number. And this is the most common type of equation that you will probably come across. Other times we'll get to a point where we have infinite solutions. And this happens when we end up getting to a point where we get like x equals x. Something equals itself. 5 equals 5, okay? We could even have like 4x plus 8 is equal to 4x plus 8. We get to a point where both sides are identical to each other. So this is called the identity. And then our last option is if we have no solutions. And that happens when we solve and we get to a point where we get two unequal numbers. And we can even get to a point where we have, like here, this 4x plus 8 on the left side. And that would equal 4x plus any other number other than 8. So I'm just going to randomly choose a number. I'm just going to say 9, for example. They're not equal to each other. There's no way that 4x plus 8 will ever equal 4x plus 9. It's just impossible. And this is called the null set. There's just no possible way the two sides could ever be equal, as opposed to here, where the two sides will always be equal. And that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye!